Welcome back. Dobro došli. And welcome back to the final speaker on the software track of the vector hack, number 3. Kevin Kripper de Buenos Aires is a generative artist whose work addresses a wide variety of topics, technologies, and aesthetics. Some of these works have been exhibited and awarded at both art and science festivals. For the last 10 years, he's been developing digital tools that expand the creative possibilities of experimental artists from all over the world. His best-known development is Vsynth, which he will be talking to us about very shortly. And he's inspired by the late 60s, where artists, engineers, and programmers worked together, co-creating technologies to liberate the spirit. Kevin, I pass over to you.
Thank you, Derek. Yeah. And a special shout out to Cliff that actually encouraged me to come here to present this, even though I think that still proof of concept of a modular environment for scan processing. And I have a presentation, but I think I'm just gonna go through all this pretty quickly, actually, and just show you something very important in 2017 that happens, which is this. I went to Signal Culture after a year that I started developing Vsynth, this, I would say, video lab for video synthesis, image processing, and video tool design. There's been people that has been using it for making their own tools. And at Signal Culture was the first time I actually saw Vsynth on an oscilloscope. Using Dave Jones' raster scan, his version of the root tetra, and I fell completely in love with the beam. And well, then I came back to Argentina, and well, some of my friends are also very involved with video synthesis and vector synthesis. And we start making some gatherings, and in those gatherings we experiment with different kind of oscilloscopes, and sometimes with lasers, very little actually with lasers. This is one of my first experiments making patches specifically for the scopes. This is using actually Javier Plano's alignment scope, which has this beautiful P7 beam, which again, fell completely in love with this, with the persistence after doing so much video feedback in general. Seeing actual persistence was beautiful. Then this is another early experiment, mostly inspired by Jerome Fenderson's patches. This is my version of the mushrooms, you know, like the flower and some butterflies. This is some years ago. And I went complete full hardcore mode into this research when I moved last year to the US. I started getting my own scopes. I started opening them, cleaning them, fixing them if I could, right? Like maybe just changing a bulb or replacing some caps. I did a little bit of 3D printing to get the hood and make some good shots. I hacked a Vectrex, so I started making all these checkboxes, you know, like going through, okay, I made this, I made that, and started to get really involved with this practice. I think that we need to kind of domesticate the technology, you know, like really get involved and know what you're doing. So yeah, I started making all these checkboxes, you know, like made my own list of weird oscilloscopes, going through different old magazines, specifying like different models with different phosphors, the range, like the bandwidth, if they are dual beam or not. I have some help here from Javier too. We started making this together. This is longer, so yeah, and I started to get in some of these scopes. This is some of the ones I have at the moment. With white beam, start making my own graticles too to change the white beam to different colors. Getting this, the middle one is my favorite. Right now it's a dual beam with P7, and it has these red lights that adds like this beautiful texture to it. And well, I ended up making my own modules. I was feeling like a little trapped just with the patches. If I learned something about Vsynth is that if you have these modules full of features, you can like really quickly make a lot of different graphics, and you know it's already like attached to Vsynth, and you can say presets and everything. So like, well, we are gonna go through this patch later, but so this is kind of a spoiler. But as you can see, like the modules that are in gray with the green band on top, that's Vsynth. The ones below are the ones specifically for the scopes. And as you can see, I'm just doing a little bit for the scopes. It's just the raster scan and the output. All the rest, in this case, is just Vsynth. And these are other experiments, kind of the root tetra in the left, and on the right, one patch that I was just doodling here, actually. I was just taking pictures of the Vectrex hacked, and, well, videos, actually. And I didn't even save that patch. And I posted in the vector synthesis group, and suddenly I started getting all these likes and comments and shares, and people start talking to me, and I was like, okay, something that we can do today is like actually patch it here all together, so you can see a little bit of my workflow too in all this. But first, let's show a little bit Vsynth, because I don't know if all of you here know it. When you download Max, you can install it for free from the package manager. And to my students in general, I suggest them to go to the launcher, which is this little box here that you can like make a new patch. Actually, let's just make a new patch from here. And you know, like if you don't know anything, you can just alt-click like normal Max MSP and go to the help file. And in the help file, you get a Learn More tab. That if you click it, you go to this kind of lesson, in which in this case goes through frequency and phase modulation, and you have like 3 different presets that goes to some basics differences between frequency and phase modulation, and it's all commented in the right. And then if you click in the other tab, is the pulse width modulation, and it's the same thing. You have presets and explanations of the presets. If you don't want to do it in this way, you can actually go through all these lessons, which are a lot. Like Vsynth is really fully documented. I've been developing this for the past 6 years, so like, anyway, you have like a lot of things to learn. It's actually a really good resource for learning video synthesis techniques, which there are not a lot of resources for that, actually. So you can go through like additive synthesis, what that means in video synthesis, subtractive synthesis, even granular synthesis. So there's example of all of that in here. Even there are Lisa Schu's patches here, which is something that we all have done with the scopes, but in this case, kind of simulating this by making just a dot with my radial waveform generator, and then just using my video LFOs to displace that in the screen, right? So it's pretty low frequency what you can do actually here with this patch of the Lisa Schu's. But then you can add some feedback and, you know, start making more weird patterns. So anyway, tons of lessons to go through video synthesis, and then you have the patchbook, which are like more creative patches to do. That again, it covers a lot of different things. That really simple stuff like making hearts, because we all love video synthesis. This is kind of cute. And then going to, so Vsynth for me, it's kind of a polymathic, kind of holistic tool in a way, because it grabs like knowledge from different disciplines I'm interested in. I'm quite a curious guy. So for example, we can go and open the gummy worms patch. I'm very interested in microscopic forms of life that you can actually get, or yeah, kind of, you can get resemblances in video feedback. So for example, this one works with the camera, but it doesn't matter actually the original image that you use as an input. So that's me. And in this feedback loop, you get up having this kind of reaction diffusion that they're the worms. And you can tweak them all in real time, so you can kind of change them. There you go. And everything has also presets just in case you screw it, because all those kind of patches, even though they're self-controlled, I'm very interested also in this term by two Chilean biologists, the autopoiesis, basically. They talk about cells that replicate themselves and self-balanced systems. So it's kind of random, but also self-controlled. So this lasts forever. But you can sometimes, if you move a parameter that shouldn't be in a specific spot, you can kind of kill it completely. But if you find the sweet spots, this lasts forever. So this is more like related to microscopy, for example. But then I found out this chemical oscillator, right? Which the first iteration of the chemical oscillator is just, I don't remember the components, right? But when you mix these liquids, you get first like yellowish, transparent color, and then suddenly it changed completely to dark blue, and after a certain time it changed again to this light yellow kind of transparent color, and forever it makes that. So I was very interested in that and make my own version of that, which was basically adding hue rotation in the feedback loop. Sorry, I forgot to say actually that the chemical oscillator then evolved, and Belousov and Sabotinsky, two scientists, added some more chemicals into it and started discovering these spiral patterns. So I made my own version of that. This is not mathematically like accurate, so this is not like a model of that behavior. It is just like a version made with video feedback that resembles that physical chemical process. And here it is. And this actually evolved afterwards to a generator. So if you go to my menu tab of the generators, you will get the chemical oscillator, which is like a short of all dispatch. And you just connect it to the output. I'm going to put it in black and white. And then you just like trigger the reaction. And yeah, it starts to make this pattern. And then you can use it as your generator. And then you can colorize this already. And so Vsynth is this set of modules mixing a lot of different things that together make this lab for me. And I started making stuff for the scopes now to add another layer of complexity, I guess, and also to reach people that are also into the video synthesis community, but using the oscilloscope or the vector displays or the lasers as their output. I'm gonna go to that right now. Okay, so I'm gonna start a patch from scratch, and like really from scratch. So I'm gonna put first the Vsynth menu, and I'm gonna also add the vector menu. And of course, you need first, like this actually works with Vsynth, and even though, like as you are gonna see, you can plug audio too. It's not that just work with Vsynth. You need the Vsynth render, so that's like the catch. You need to download Vsynth in order to use it, even though if you're not gonna use the Vsynth modules. I'm just gonna add here. Let's see, the 3-channel output from the vector set of modules, which is going to be connected to the XY display. So if we can turn the picture-in-picture, that would be great. Great. So we have now the dot, and I can control the brightness directly from here. Oh, this one is okay. I can also like turn it off completely also. So even though for now I don't have the menu separated into the different categories, it's still kind of the same as Vsynth. We have some global modules, we have inputs modules, we have generators, we have the outputs, we have processors. I just haven't separated into modules because I literally put together all these modules during this summer, actually, even though I've been working with this stuff for longer, like putting together everything was my summer project. Yeah, so I'm just gonna add a generator, which is gonna be the raster, let's say. So one thing that I was struggling before making this was the amount of patch cords I needed to use in order to make all this stuff. You have X, you have Y, you might have set, you have brightness, and you have, in my case at least, you have horizontal and vertical sync. So that's a lot. So I'm using here a new feature from Max that I found very useful for this, which is the MC feature, which means multi-channel basically. And so each patch cord can share or carry up to 64 channels. So that's very convenient. So in this case, my output from the raster is one of the outputs is carrying XY. So if you just plug XY, like the output from the raster to the 3-channel output, and if I turn on the brightness, we already have the raster there. So okay, so there is something. Oh, we also have a preview here of this, which is quite reliable, even though it's not like really HD. You know, like it doesn't have a full resolution, but it's reliable. So I don't like the flyback, right? Like the line we have in the right. So the second module I built is the edge fade, which is a weird name for this, but I'm kind of using syntax from video. So an edge fade in general, when you are doing projection mapping with two projectors, when they overlap, you do the edge blend or the edge fade. So the two projectors looks like one, but basically what you're doing is just fading to black the edges. So basically this needs the sync. So as you can see this, I don't know if you can see it correctly. Yeah, well, it receives the brightness and the sync. So if I grab the sync from the raster and I connect the output of the edge fade to the input of the brightness, I can get rid of the flyback very quickly and just basically do the same to all the edges of the raster. Okay, and this is only working because the edge fade in the inside has a pre-patch steady signal, like in the like super bright. So that's why it's working. Then things from the brightness that are like, from the raster that are very common is like the amount of lines you can choose. There is one difference in general that I found that all the rasters you cannot do floating numbers, so you cannot do like a smooth transition between the lines. It's like steps. So in this case, I fixed that, and you can like add very smoothly the amount of lines, and then you have, and it doesn't like beat, so it doesn't start scrolling when you are using floating numbers. You have another control, which is the speed, so you can just have this linear animation separately of the amount of lines. And then, of course, the refresh rate and some here controls from the brightness. So let's actually do something with this. I'm going to add here from Vsynth the polarizer waveform generator, which is a wave shaper and a shape shaper. So I'm going to also add a preview here so you can see it. So it makes the lines, and you can wave shape between the different waveforms, but also you can change the stripes for some radial shapes. So it's kind of convenient to try things very quickly. So I'm just going to plug this into the X modulation, which basically is the X and Y deflections. And as you can see, the inputs of the raster have these lines. That's because they are all pre-patched. So whatever is coming to the X, it's going to the Y, and it's going to the brightness. So actually, if I plug the brightness to the edge fade, that is going also to the brightness output, we start getting already the circle in the brightness, right? And I'm going to add more lines so you can see it better, like 50 lines, something like that. And well, that's going to the brightness. but also that. Okay. I'm just gonna do it from here, actually. That's okay? Cool. So anyway, this might be confusing because I'm not applying actually nothing to the brightness input, right? But since it's pre-patch, it's actually getting what's coming from the X. So if I grab another polarizer generator and I plug it to the brightness, it's changed automatically to the stripes, which is what's coming out from here, right? But I still get the display. I'm still going to get the circle for the X and Y. So if I change here the attenuators of the deflections, I'm just going to get this shape. And at the same time, remember that I'm using the stripes for the brightness. So you can start getting a lot of different interesting patterns. And if I just delete this cable, now the circle is also going again to the brightness, so you get this shape. If you have any questions in the middle, let's make this interactive. It's fine by me. Okay. So that's it. Then it's also weird because we can go two different ways here. Like I can even just make a sine wave from max, I don't know, let's say 6.60 Hertz .1, and plug that to the Y. So now the circle is going to be displaced in X, and this sine wave is going to be displaced in Y, and the circle is going to still go into the brightness, right? So that's I'm actually going to put a number box here so I can change this on the flow. So now you can see that my sine wave that I'm generating from max is an audio, like sine wave. It's modulating the Y deflection. So you can basically put any audio input you want, your modular, or even like Max comes also with beep, which is like a high level, also modules like Vsynth, but for audio. So if I just grab whatever, like the oscillator, the most basic one, and plug it into here, still working, right? Kind of high frequency, but so basically you can start mixing video signals, audio signals from Max, from other softwares, from your modular. So this is really modular. That's what I mean. So yeah, and if you just delete, since it's all pre-patch, it comes back to the original signal that it's coming to the X.
Kevin, I've got a question from the YouTube people. Actually, this is a question from James Lehman. He was asking if the audio signal is connected to the oscilloscope, which I said yes, that's what's driving the beam. But he wanted to know what the audio sampling rate was, because it's quite detailed.
It's the highest, 192.
Yeah, that's what I thought. Great, thanks.
Also, I have to say that this sound card, it's pretty sharp. It's the Presonus Studio 26C. Just channels 3 and 4, channels 1 and 2 are pretty noisy. So if you get this sound card, use channel 3 and 4 for X and Y, and channel 1 or 2 for the brightness. And that's going to get like the sharpest line, at least in my experience using this. So other things you can do here just directly from the raster is inverting the brightness. So that's what you get when you invert the brightness, change completely the shape. Yeah, and then it's like you can add audio effects, because what's coming in, this is the complex part, and that's why like Vsynth, it's easy because it's all textures basically, it's all like video, but these modules can get video, audio, but speeds audio, and what the audio that it speed, it's multi-channel in XY, it's a mono signal in the brightness, and it's a multi-channel signal in the sync. So you really need to know what you're doing, or understand like how all this is like connected, because it started to get quite complex. And you can add audio signals out like in the middle between the raster and the output in this case, or you can add whatever module of Vsynth you want to use before going to the raster. So for example, classic stuff too, like I'm going to add just a pixelator. and decrease the resolution. I'm gonna also connect the preview here so you can check it out better. I'm just gonna put 4, right? And you get this. And another thing you can do with just this module is interpolate the pixelation. So instead of having like sharp squares, you will get like a diamond gradient to the center of these squares. And it changed again the flavor of this. And you can also like put 6 here and or change. And you can start making different shapes just by moving knobs in the polarizer generator.
I'm going to jump in with one more question,
Yeah.
which is right now we've got a kind of a pseudo 3D effect, the pseudo extrusion 3D effect, because you're applying the displacement from your waveform generator to both the X and the Y. So you've got this kind of diagonal displacement that makes it look like it's popping out, but it's popping out up towards the corner. Do you have something that also does perspective that actually takes X, Y, and Z and projects them down to X, Y?
No, so yeah, the 3D part is in development, but what you can do is using the displacement module or the stretcher. In this, I mean, both of them are gonna work. It's just one have more options than the other one. So I'm just gonna go with the displacement, which is quite a huge module. Hopefully, and this is exactly the same module as the displacement 2 from Vsynth, only that this one it's more compact. So you have in the first row, you have the initial points, and in the second row, you have all the modulators, and in the Vsynth module, it's just like a click to change it's just smaller. So I'm gonna plug this here. I'm going to delete this, put it in 0. And then I'm going to grab the brightness and send it directly to the scale, which is doing basically amplitude modulation. And if I change here the 0, it comes towards me now, but still flat. Because if I put, this is like the 3D in development. So, so if I put the 3D rotation, that is the only 3D module I have for now, you can plug it here. And as you see, if it rotates and it's still flat, right? So if you plug the brightness to the set modulation input, you can see that now has some depth. But yeah, but it's just rotating with 2 LFOs because I didn't add any like any rotation number box or knob, which is just adding that. It's already there. I just put 2 ramps, so it rotates automatically. But that's the only rotation, only 3D I have right now. But I actually do a lot of things with the displacement with are really cool, kind of 3D. But let's do that a little bit in a few minutes. So I can show, because this is basically your raster processing. So I have like different rasters, and I'm developing some more. So I'm gonna put really quickly the grid, for example, and the grid, it's fine, Derek. I have the same scope, it's fine. So yeah, the same things apply to the grid, right? As you can see, it's the same as the raster, it's just making the grid. So if I plug here, nothing happens because nothing is going to any of the inputs. So I'm just going to put, for example, this here, and as you can see, it's kind of another kind of raster based on a grid. And same. You have the deflections, you have the inversion in the brightness, you have speed for the horizontal lines and speed for the vertical lines, the amount of lines, the direction, right? And I have another one right now, which is the polygon raster, which basically, if you put just one cycle and change the phase, you will get, well, in this case it's a square because I have 4 vertices, right? But if you put 3, you have the triangle, and you can rotate it and all that stuff. But the cool thing is that you can add repetitions. So this can also work like kind of a raster, right? Just gonna plug this here, and again, I can start like modulating this. So, and I have some other parameters here, like some kind of asymmetry, Y again, and I can plug to the Y another shape, and it's gonna make a different kind of distortion for that deflection. And yeah, that's basically that for now, the generators. I have some more in development. And then it's basically some effects, right? Like a fisheye. Let's actually use the grid for this. Just a fisheye, or you can go negative numbers to the anti-fisheye. I have also a twirl. This was very interesting research, actually, because some of these algorithms are pretty much the same as in computer graphics. So I've been, like translating some of the Vsynth modules into the audio realm, and they work basically the same. So that's the twirl. And it can also rotate automatically. Like it has a linear rotation. Then we have like a cropper, which I have a cropper. The cropper works pretty much like the X-fade, but since it's not working with the brightness, you will still have the lines, right? So you're just cropping. And it has these like symbols here in the middle, which you can like sync. So now you control both of them at the same time, so the movement is even. And then, then it starts to get more complex, I guess. Let's add again the raster. And make a figure, because one thing I didn't mention is that you can, this is well known, right? Like if you crossfade, you are actually morphing, and to make an actual crossfade, you need the brightness. So for that, I have the crossfade module. It's just named like that, and the crossfade module receives two signals that are X, Y, and B, right? So I need another module in the middle, which is the XYB compose. So basically, what you can do here is send the XY to the XY, and send the brightness to the brightness, and let's send something to the brightness actually. And the output of the XY compose goes to the crossfader, and the brightness of the output is still X, Y, and B. So I'm doing this of like merging and splitting signals pretty much all the time. But the patches looks pretty clean in the end. So, and I'm gonna make another kind of shape now with another raster. Let's do this. And put one of my previews of audio. This is also another module. You can have like previews in the patch that can also go full screen, or like a floating window. So you can have several windows. The one that we are watching here is the one from the output. You are watching it, right? Okay. So in this one, let's just like make a little shape. And I'm gonna morph, right? So in morph mode, you basically morph between the two shapes. And let's stop it here. And
is this simply crossfading brightness, or is this doing some multiplexing?
This is just the morph, but then in the menu you have the mix. With the mix will be the multiplexing. So now, as you can see, it started at least in the scope, it started flickering a little bit, and then I will have to increase the brightness. And as you can see now, it's like they are both there in the screen, right?
Can you change to morph now to see just what that does?
Yeah.
Okay.
So it's
okay, this is real morph. Great.
That's the morph, and then this is the mix. And to see both of the shapes at the same time, you just put 0.5 in the slider, and you have them there. But the thing is that you compose. I'm interested more in the light sculptures rather than in the what you hear is what you see, you know. So basically, the idea is that you compose your figures first. Everything goes to the X, Y, B compose, and then you start like mixing. So for example, one of the modules I'm making is like a sequencer. So it will receive X, Y, B, all the channels, and you can switch between already made shapes that are based on X, Y, and brightness all together.
What exactly does XYB Compose do? Is it simply put them all into one cable?
Yeah, it's basically, well, I like to make things for dummies. So it's inside of that module, it's basically an MC Pack 3, which is the module that allows you to merge 3 audio signals into one audio signal, but with like a user interface, very silly user interface. But then once you compose, like here are both of the shapes the same size, so why don't we use the transient scale, which basically offsets and scale your signals. So let's put this here. And also another one here. And what did I do wrong? Oh, I know what I did wrong. It has to be before the XYB compose because the transient scale receives just XY. So yeah, the XY compose, it has to be the like last module before you start crossfading or changing shapes. Just gonna put this here. Increase the brightness again. Okay, so now I can scale one, scale the other one. One goes to the right or to the left. And then, yeah, when you know, like they are doing like the multiplexing thing. Actually, I was inspired by Derek's talk in 2018 with this. And actually, the output module, the way you choose your outputs to the sound card, it's basically your same interface, right? The only difference, I think, is that I have a JSON file that the user can change. So, for example, I don't know, you don't have 3, 4, and 1 for X, Y, and B. You have 1, 2, and 3. So in this JSON file, you can change that. So every time you open the 3-channel output, you have 1, 2, 3, instead of having to change every time that kind of things. So yeah, what else?
I'd like to open it up and see very quickly. I've been monitoring, and there haven't been any obvious questions on the YouTube. But does anybody here in Šibenik want to ask something? Anything? Let's hear the sound from.
Oh, that's I asked for no sound, so it's pretty synced, and so it's kind of hard to to dig this sound, you know. I think that if you want to use it for more musical purposes, you will have to like process it with other thing, and yes, what you are seeing is not actually what you are hearing, because you're gonna do other process afterwards. But yeah, it's pretty synced. It's hard to hear. I don't like it actually. Yeah, it's pretty hard. Yeah.
Can I ask a question?
Yeah.
I'm intrigued by the XYB compose element. How easy is it to make an XY RGB compose element?
You can do that completely because these channels, this feature from Max allows you to transport up to 64 channels per patch cord. So you can have, for lasers it's perfect too.
Okay.
Yeah. Actually for lasers, what I would do is to have XY and RGB separately.
Okay.
Like 2 patch cords only. Yeah, that's really neat. Actually, when this feature came out, I was like, okay, I think I should start like actually developing now this tool. Because before I was like pretty bummed every time I had to patch. This was like a lot of patch cords everywhere.
Nice. Thanks.
Yeah.
It's super efficient. James Lehman, has been asking a couple. Well, he said a couple of things in the chat there. He says, for one, he's actually amazed by the connection between video and audio, and he wants to know: is there a low pass filter? Is there a way to kind of reduce the amount of information so that it could be safely plugged into a laser?
Well, I mean, that's the cool thing. Since it's in Max, I don't have to develop everything, right? So I'm making only these like really high-level modules specifically for some specific features, and then you can just like grab a Max filter and put it in whatever part of the chain you want. So there's a filter. This doesn't come with a filter. But yeah, you can put a filter, like a B-Qual from Max. This is a classic one. There are several. Or you can grab one from Beep. So there's like, it's plenty of this kind of stuff already done. I don't want to reinvent the wheel here.
It's great to be able to leverage all of the other libraries and sets of objects and sets of abstractions, if they call them abstractions, in Max that are out there. And actually, it's very nice that both Max and PD have their own systems to be able to very quickly import these user-contributed libraries into this environment. It really expands the sets of possibilities and lets you start to mix and match things really, really quite nicely.
For sure. Yeah. So well.
Yeah, we're just at about time. I'm going to stand up and look back and see if there's any hands in the air for a question.
Yeah.
Cliff again.
I'm curious about grid
Yeah.
raster generator, because I know about, well, normal rasters, but I'm actually confused of
About the grid?
yeah.
What
Take a raster and rotate it 90
exactly.
degrees every other frame.
Yep, that's what I'm. That's what I'm doing actually. It's not what James would do, for example. But yeah, I come from like my only degree is in electroacoustic music composition, right? So I come from audio. So my approach to all this is like that. So the only way I found to make the grid was just, as Derek said, crossfading with a square wave between the horizontal and vertical raster. And the poly raster, the other one, that's another like lateral thinking way to solve it. I just basically make a line. The line I subdivide it in like steps, and then I rotate all that very fast. And that's how you get the polygons. But again, that's like my approach to all this is not like maybe the most efficient, but it works. I mean, so yeah, and I want it to work.
I'm fully in support of the chewing gum and coat hangers school of engineering as well. So.
So I was planning to actually, since there was a lot of really good feedback of this specific doodle, to patch it now with all of you. I don't know if we have time for that, but
We're kind of at time for this particular presentation because it would be good to take a short break before we come together to have a discussion. So,
all right, I'm gonna make a tutorial then.
You should make a tutorial because I think you'll get many likes,
Likes, right.
lots of thumbs ups. Let's put our hands together. Let the avalanche of YouTube emoticons commence. Muchas gracias.
De nada. Gracias a ustedes.
All right, we're going to take a 10-minute break. We're going to come back at approximately 1:15 and bring together our speakers for a little discussion.